a start. So thank you to everybody for joining us for this briefing. My name is Caroline Lucas. I'm the MP for Brighton Pavilion and the chair of the all-party parliamentary group on climate change. And we are very pleased to be co-hosting this session alongside Peers for the Planet. It is a real privilege to be joined by some of the UK's leading scientific experts, Sir Patrick Vallance, the government's chief scientific advisor, Professor Stephen Belcher, chief scientist at the Met Office, Professor Emily Shuckburgh, the director of Cambridge Zero, the University of Cambridge major climate change initiative, and Professor Gideon Henderson, the chief scientific advisor for DEFRA. Thank you so much for all of you for sharing your time and expertise with us today. In the last 12 months, we've seen a succession of major reports from the IPCC warning of the severity of the climate emergency and the growing urgency of emissions reduction. Take this, for example, from Working Group 2 report, which states with very high confidence that, and I quote, "The scientific evidence is unequivocal. Climate change is a threat to human well-being and planetary health. Any further delay on adaptation and mitigation will miss a brief and rapidly closing window of opportunity to secure a livable and sustainable future for all." I don't know about you, but quite frankly, I think that is a terrifying warning. And as we know, the climate emergency is no longer just some future concern. It is happening right here, right now, quite literally. The worst flooding in a century has killed at least 100 people in Bangladesh and displaced hundreds of thousands. We're seeing record-breaking heat waves in Europe. The US is set for another scorching wildfire season. And it's unsurprising, therefore, that climate change is consistently a top concern for the public, and that 60% of young people are very or extremely worried about the climate emergency. Yet despite the dire warnings and the warm words at COP26 in Glasgow, the world is still not on track to limit global heating to 1.5 degrees. We're not even close. And at home, despite the UK retaining the COP26 presidency, we're still not seeing sufficient progress. Just a few weeks ago, the Climate Change Committee warned in their 2022 progress report to Parliament of a lack of delivery and what they termed a high-wire approach to net zero. Indeed, there are either significant risks or a total policy gap for 38% of emissions that are needed to meet the sixth carbon budget. Now, the UK kicked off the Industrial Revolution and was also the first major economy to enshrine net zero into law. Our leadership on the world stage really matters. And as legislators, it's incumbent upon all of us to act and to understand both the risks of failing to do so and the opportunities that are there if we do act now. So without further ado, I'll now hand over to Sir Patrick to start off the presentations, and then we'll have about 40 minutes at the end for questions, which will be held under Chatham House rules. So although the briefing is being recorded, our question and answer session won't be. So let me hand over now to Sir Patrick, and many thanks again for joining us.
Thank you very much, Caroline, and thank you everybody for joining us. We've had 2.5 years of a global crisis in the form of a pandemic. We face 50 years of really big problems relating to climate. And that nature of that threat to countries around the world means that this has to be one of the things that is absolutely on every government's agenda. There's no way that we can just ignore it. There's no way we can pretend it isn't happening. It is going to be the thing that governments around the world need to focus on. And to give just 3 observational facts, so not things that are extrapolated or things that people are interpreting. The world is warmer than it was. The CO2 levels in the atmosphere are higher than they've ever been. And extreme weather events are more common than before all this happened. That's what we face. And the aim of this briefing, and I'm really pleased to be joined by 3 expert colleagues who have already been introduced, but I mean, I think it's worth saying they really are deep experts in this field. The aim is to speak about the science. We want to try and give you an update on what the science is currently saying, so that you, as the people who are going to be debating and making decisions on this, are informed and are able to make your decisions with the information at your fingertips. So we're talking about science, We're not talking about the policies, which are obviously things that need to be determined by governments and need to be implemented. But clearly there are consequences of what we're going to say. And science has been instrumental in detecting the problem, in describing and monitoring the problem, and is important for the solutions, whether that's solutions towards mitigation or, as Caroline has already said, towards adaptation, because whatever we do, the changes that have taken place are baked into the system. They're not going to go away, they're going to increase over time, and therefore we need to be able to adapt to what is a changing environment. And it's not, of course, a parochial UK issue, it is a global issue, and it's one for governments around the world. I want to make just 3 points before I hand over to my expert colleagues. The first is that technology is going to be an important part of dealing with this, but it is not a magic solution and it will not solve it on its own. So we do need technologies, we do need to invest in technologies, we do need to continue to invent. But if you take 2050, any technology that you can't sort of see to some extent already is not going to save our bacon. It's absolutely not going to get us out of this because of the scale at which these things need to be introduced. So we need to continue to innovate, continue to discover, and to continue to implement, but we also need to really push hard now on the implementation of the things that we have. And we need to accept that technology alone won't get us out of this. The second is that the timescale of this is such that 2050 is not a long way away, it's actually rather close. And this scale point that you can't get things done at scale if you leave them a long time. That's why now is an important period to be thinking about this. And the third general point is this is a systems-wide problem. It affects virtually every part of every department, and therefore you need to think of this as a systems approach. It can't be one where you cherry pick the odd thing and hope you're going to reach the solution. And if you want to see more on this, there was a letter that we wrote from the Council of Science and Technology 3 years ago, describing this as a systems problem that needs to be approached as a systems problem by government. And that's also important because some of the actions that people might take may pull in the other direction from the one you wish somewhere else in the system. So viewing this in its totality is crucial. I will stop there and I'm going to hand over to Stephen Belcher from the Met Office, first of all, who will give an update on the climate science. Stephen.
Brilliant, thanks Patrick. I had assumed that someone from the central office was going to share the slides, so schoolboy error for not checking ahead of time. Caroline, is that possible? Someone can help us with that?
I'm hoping somebody from Policy Connect is going to be able to do that.
Well, while they're doing that, let me just say that it seems fitting to be giving this presentation on the day that the Met Office has just issued an extreme heat warning for next Sunday, likely to go into next Monday as well. We're watching things very, very closely. Temperatures have been exceeding 30 degrees over many parts of southern central England and the east. I'm in the southwest where it is a little cooler.
Can we check that the slides are coming up?
So I think your colleagues from your office are in the event now and should be able to share them.
That was our understanding, sorry, that it was your colleagues who were going to...
Okay, I'm going to just nip out there and see whether somebody is doing that.
Brilliant, thanks Patrick. So I sort of have three elements I'd like to address in my introductory remarks. The first is observed indicators of climate change and the connection to greenhouse gas increased concentrations in the atmosphere. So this is purely observing the climate system and watching how it's changed over the last 150 years or so. The second element is then to make the connection between that observed change and what we need to do to stabilize climate, i.e. to get to net zero emissions. And then the third bit is to really reiterate Patrick's point about urgency, and the longer we delay before cutting emissions, the faster we will have to cut emissions if we are going to keep 1.5 degrees within reach.
Okay, this is a bad next slide please moment, and I will go again to see if we can get this connected.
Aha.
There you go.
Next one, please. Okay. So starting with what do we see when we look at the planet and the climate over an extended period of time? So bottom left-hand plot, you will have seen before. This is the global mean temperature. It's the famous HAG-CRU-T, so Met Office plus University of East Anglia, thousands of observations around the world to estimate the surface climate and how that's changed over the last 150 years. So this time series starts at 1850, ends at last year. And what you can see is in the first 50 or so years, it's wavering around 0 because that's the baseline that we've checked these data against. And then since 1980, a warming of the climate system. So we breached 1 degree in about 2015, and we're now about 1.2 degrees above that pre-industrial baseline. The second indicator that's shown here on the top right is carbon dioxide concentrations. So the present day is 0 on this plot, and my apologies for the change in baseline. So that is today. And this goes back 100,000 years. So this is to put those carbon dioxide concentrations into a geological context. And what you can see is that between 100,000 years ago and really very recently, the carbon dioxide concentration has bobbed somewhere between 200 and 275 parts per million in these units. And then there's the big ramp at the end where the carbon dioxide has really increased very, very sharply, right in the far top right-hand corner of the slide. And really the point of this is to show that those carbon dioxide concentrations that we have now, 414.7 parts per million, is unprecedented in the last 100,000 years. And to put that into context, the plot here shows the emergence of Homo sapiens. So this is a very long time, and it's a very unusual event to have such high carbon dioxide concentrations. I will connect those two things in just a minute, but if we could move to the next slide, please. The changes that we observe in the climate system are not limited to temperature. There are many, many other indicators of change. And I will say again, these are just observations. There is no modeling involved in these. This is observing the planet and what's happened over the past decades. So top right-hand chart shows sea level rise since about 1990. And this is the satellite era when we were able to measure sea level globally. And it's a global average of sea level rise. And you can see a consistent increase in sea level during that period. So it's one of the most pervasive indicators of climate change is the sea level. And you're seeing data here from a whole host of different sources, all showing this consistent rise over that 30, 40-year period. And I think Gideon's going to pick up on the sea level rise later in the presentation. The fourth and final indicator that I'll highlight here is Arctic sea ice loss. So it's one of the rapidly changing areas of our climate system right now. Again, since the satellite era in around 1989, 1990, we've been able to monitor sea ice extent in the Arctic around the North Pole. It varies throughout the year, but what we do see is that over the last 40 years, the minimum of that sea ice extent, which happens in September, has reduced by about 12% every 10 years. 12% every 10 years, that's a big number. And what the maps here show you is to give you some sense of what that means. So every year, on average, we're losing an area the size of Scotland. Every 10 years over those 40 years, we're losing an area of the UK, equivalent to the UK and France. And over the whole 40-year period, the Indian subcontinent. So we're losing very large fractions of Arctic sea ice. If we could move on, please. So those are indicators of the changing climate. What I'd like to do next is connect these changes to increased greenhouse gas concentrations. Are we able to move on, please? My faithful assistant has gone to help. Okay, so we have two charts here, and here we're using a combination of observations and climate models. So on the left, it's the global temperature in the black curve, again since 1860 to present day, relative to that pre-industrial. So we've seen that before. And the red, blue curves and the yellow lines are climate model simulations, but using pre-industrial levels of greenhouse gas concentration. And you can see that the rise in global mean temperature that we've observed since 1980 is outside of the range of these climate model simulations. So that's the counterfactual world. And I had a friend who was a historian, and he used to say there was a fashion in history where what would have happened if Hitler wasn't born? So this is the climate change equivalent. What would have happened if we'd kept our CO2 levels at pre-industrial? The right-hand panel shows those model simulations with observed greenhouse gas concentrations increasing through the 20th century. And you can see now that the red and the blue curves, which are the average of the model simulations, really match the observations very, very well. So using this and other similar lines of evidence, we can say unequivocally, and that's an extremely strong statement for a scientific community to make, that human influence, i.e. greenhouse gases, has warmed the atmosphere and the ocean and the land. So that's connected the observed change with carbon dioxide, methane, and the other greenhouse gases. And if we could move on to the next slide, please. So what I'd like to do next is motivate net zero. So we've connected climate change observations with carbon dioxide. The tricky thing about carbon dioxide as a powerful greenhouse gas is that it stays in the atmosphere for decades. So what we're looking at on this chart is a relationship between the accumulated carbon dioxide that is accumulated in the atmosphere because it stays there for a long time once we've put it there, the carbon dioxide that's accumulated in the atmosphere since the beginning of the Industrial Revolution, that's the horizontal line on the chart, versus the global mean temperature rise, so the global warming, which is the vertical axis. And the black crosses show the relationship between that accumulated carbon dioxide and the temperature for the past decades. And you can see they sit pretty much on a straight line. So as the carbon dioxide accumulates, so the global temperature warms roughly as a straight line. And there are theoretical reasons for thinking it's close to a straight line in this range. What this tells us is two things. Firstly, every additional ton of carbon dioxide that we lodge in the atmosphere is going to warm the climate. So if we want to stabilize the climate, we've got to stop emitting, or we've got to get to net zero of carbon dioxide emissions and stabilize the carbon dioxide concentration to stabilize the climate. The second thing that this plot shows in the gray cross is where we'd like to be, which is to keep climate below 1.5 degrees above pre-industrial. That's the Paris Agreement. And you can see there that we haven't got much more carbon left in the bank that we can put in the atmosphere if we're going to remain below that level. It's probably 20 to 30 years at current rate of emissions maximum. If we continue to emit as business as usual, our best estimate is that red curve with 2.5 degrees or so of warming by 2050. So this is where the choices begin, depending on whether we aggressively reduce emissions or whether we continue. If we could move on to my penultimate slide, please, before I pass to Emily. So just taking a global picture when the slide comes up on the need for urgency. The chart on the left-hand side shows the emissions of carbon dioxide per year, and the black line is what we've observed up until about 2020. So an increase in the amount of carbon dioxide we're putting into the atmosphere each year. You'll remember that every ton of carbon dioxide we put into the atmosphere warms the climate. So if we want to stabilize at 1.5 degrees, it's the area for the scientists amongst you under that graph that matters, meaning the later that we leave the cut in emissions, the more rapidly we need to cut emissions. Hence, the blue curves get steeper and steeper. So this is the scientific articulation that if we want to stay below 1.5 degrees, the longer we leave the reduction in emissions, the more rapidly we will need to do that. And this chart quantifies that statement, but it's reaching very urgent to keep 1.5 alive. The thermometer on the right-hand side says where we are now. So we're currently at 1.2 degrees of warming in 2021, latest figures from Met Office. We'd like to stay below 1.5 degrees. If we take all of the pledges from the 2030 targets and assume that they will happen, that will get us down to 2.4 degrees. So fantastic progress, but it needs to be achieved. If we take all of those 2030 targets and the net zero pledges and all the pledges made at Glasgow, that will see us to something like 1.8 degrees. So it's above 1.5 degrees, but we are on the right trajectory if we can achieve the commitments that have been made to date. Still a long way to go, and implementing those, as Emily will speak to, requires huge action. And if we could move to the final slide, please. So the final slide is a reminder, as Patrick introduced, that if we look back even over the last 2 years around the world, the number of climate extremes that we're seeing have been really quite sobering, ranging from the European flooding, the North American heat wave from last year, and this year India and Pakistan have experienced temperatures exceeding 50 degrees centigrade. What all these events have in common is that we're able to estimate how much more likely these events are because of climate change, and they are more likely. The degree of more increased likelihood depends on the event. North American heat wave is virtually impossible without climate change. So I will pause there and hand over to Emily, who's going to pick up on the carbon budget point. Thank you.
Thanks. And we're going to run through all the presentations and then open it up. So Emily, thank you for doing this.
Thank you. And I'm going to share my own screen in the hope that that's going to work better. Can you see anything?
Not yet.
No. There we go.
We can now.
Right. Okay, so I'm just going to recap on where Stephen left things off. So carbon dioxide levels are higher than they've been throughout all of human history, prehistory and beyond. We're at about 1.2 degrees Celsius of warming compared to pre-industrial times. And the impacts of climate change are now being felt in every region across the world. Further heating of the planet would result in even greater risks to people and to nature, and would threaten catastrophic changes occurring, such as the loss of the vast ice sheets covering Greenland and West Antarctica, which would equate to many meters of sea level rise. And that particular last point I emphasize particularly because I myself spent more than a decade studying the polar regions at the British Antarctic Survey, and it's one of the areas that causes me greatest concern about the future. So last year, the Glasgow Climate Pact, agreed at COP26, recognised that to limit global warming to 1.5 degrees requires almost halving global carbon dioxide emissions by 2030. That's backed up by the science, as Stephen just emphasised, and also that we need to reach net zero by around about the middle of the century, with deep reductions in other greenhouse gases as well. And the Glasgow Climate Pact also called for accelerated action this critical decade. Net zero emissions has become the standard goal throughout much of the world, with many countries putting forward pledges, but still there's more to be done to turn those pledges into action. The UK stands out with an ambitious target to be net zero by 2050 and a strategy with detailed plans for near-term reductions in emissions. And that's what I want to discuss more about. Now it's the time for turning ambition into action. It's time for delivery and implementation, and it needs to result in real change across society, setting us on a course for a greener, healthier, and more resilient future. The UK has made considerable progress on the journey to net zero. Over the last 3 decades, and you can see the data in the graph at the top there, territorial greenhouse gas emissions, the blue line, those that are produced within UK borders, as well as the UK's share of international aviation and shipping, have almost halved. 80% of those emissions come from carbon dioxide, but other gases such as methane, nitrous oxide and fluorinated gases are also significant. Over the next 3 decades, these emissions need to reach net zero. Consumption emissions, shown in pink on this graph, those are the ones that take into account emissions produced overseas, have also fallen, although predominantly, as you can see here, only in the last 10 years. And crucially, the other line on this graph is GDP per capita. And so these drops in emissions have occurred at the same time as the UK economy has grown. Now, this graph then starts to look at the UK economy by sector. And we can see here which sectors have contributed to that drop in UK emissions that I've just shown. The line that really stands out is that blue line, which is emissions from energy supply. And they're now 30% what they were in 1990, predominantly as a result of phasing out coal and developing low carbon sources of electricity generation, such as wind, solar and nuclear. In 2021, electricity generation emissions represented 11% of UK greenhouse gas emissions, and that primarily came from gas-fired power stations. The UK is committed to fully decarbonising electricity generation by 2035, and that means that further scale up of renewables is going to be required. Today, the largest emitting sectors, as you can see, one of them shown here is surface transport. That's mostly cars. The other one is a combination of some of these other sectors that are shown here, and that's buildings, mostly heating our homes. And there's significant contributions from other sectors of the economy. If you look at that orange curve, which is the transport, you see a sudden drop in the last couple of years, and that was entirely due to travel restrictions and guidance associated with the pandemic. And aside from that anomaly, the concerning aspect of this graph is that apart from energy supply, there's been very little change in any of the rest of the sectors to date. So Caroline mentioned at the start, in its recent progress report to Parliament, the Climate Change Committee provided an independent assessment of the UK's plans and gave a rather mixed picture. Overall, they found that if delivered in full, the plans would provide the required emissions reductions by the mid-2030s to set us on a course that's consistent with our obligations and commitments. But they estimated that a quarter of the plans had some associated risks. So if you look at the graph here on the left-hand side, that's showing the overall assessment of those plans, and the yellow area is where there was an assessment that there was some associated risks. The orange area, which represents a third, indicates significant risk, and then there's 5% which were characterized as being completely insufficient that are shown in red. And if you look on the right-hand side, you see that broken down according to different sectors. So in general, if you look at surface transport and electricity supply, the assessment was that there were credible plans in place, whereas across other sectors, you can see there's significant uncertainty still in terms of the plans that have been put forward and whether or not they're sufficient to deliver on the ambitions. The particular concern about lack of detailed plans for decarbonisation of homes and of agriculture and land use. And the committee also noted an opportunity to bolster consumer-led trends in terms of healthier, lower meat diets with policy instruments, reinforcing something that Patrick said at the start, that this is not just about technology, this is also about behavioural change that's going to be required to reach net zero. So what I'm going to do is I'm going to just take a deep dive into a couple of different sectors, just to give you a flavour of the challenges across those sectors. The first sector I'm going to do a deep dive on is surface transport, and that the dominant cause of emissions from surface transport, if you look at the figure on the top left of this plot, is from domestic cars. The pre-pandemic part of that plot, you can see, is largely flat, and that's as a result of a trend towards driving larger vehicles and driving more miles that's offset modest improvements in the efficiency of new cars. But at the same time, we've suddenly started to get electric vehicles coming on board, and that electric vehicle transition is accelerating rapidly. So transport is a sector where, although we might not have seen significant changes to date, there's very much expectation that we will see a significant drop in emissions over the coming years. By December of last year, a quarter of all new cars sold in the UK were battery electric vehicles. Almost all major manufacturers have now committed to focus on EVs, and there are now over 50 models of electric car that are available and 10 models of electric van. A near-term future without petrol or diesel cars, which was inconceivable just a few years ago, is now very much within sight. The relevant charging infrastructure is being rolled out, but it needs to be scaled up, and uneven geographical coverage needs addressing. And the electric vehicle transition also needs to be accompanied with a greater emphasis on healthier forms of transport, walking and cycling, and improved public transport provision. And the dramatic growth, if you look at the chart on the right-hand side of this plot, you can see, including with the surface transport, is also a description of international aviation and shipping. And in particular, you see between the top line, which is 1990, and the bottom line, which is 2019, that dramatic growth over the last 3 decades in the emissions from international aviation, and that also needs to be addressed. So that's just a sort of synopsis of the challenges associated with transport. The second deep dive I was going to do was on buildings, and if you recall, I described how this was an area that the Climate Change Committee had called out in its recent report as being a particular challenge. Reducing emissions from buildings, most of which comes from burning of gas and oil for heating and for hot water, is challenging. Emissions have changed rather little over the last 8 years. There was a decrease that came about predominantly as a result of greater insulation being adopted in homes, but that policy came to a halt in 2012, and the emissions reductions came to a halt at that point. It's estimated that 3/5 of homes have low energy efficiency ratings, and surveys suggest that most people are not considering at the moment making any improvements. At a time of rising energy costs, this really does seem like a missed opportunity to reduce emissions and energy bills at the same time. And past experience indicates that householders with the right policies in place will put greater insulation in their homes. The other side of this is around looking at alternative ways of providing heat into homes, and the installation of heat pumps increased nearly 50% in 2021, but it remains very low, and it needs to increase more than 10-fold over the next 6 years to meet targets as a country we move away from gas boilers. The rapid rollout of heat pumps, the installation of heat networks and energy efficient retrofits will require skilled workers in construction and other related trades. And this is both an opportunity with an estimated 240,000 green jobs available in the sector, but also a barrier as lack of trained installers and retrofitters limits progress. And in an area that has such a clear impact on people's lives, broad public engagement in policy design and implementation is clearly essential. Now, many of the solutions to net zero challenges require radical whole systems approaches with really holistic views associated with them. And I wanted to give you one example where that's really being brought together. And it's an example that I and colleagues at the University of Cambridge are working on. It's associated with the East Anglian Finlands. This is a region that is at significant risk from climate change, and at the same time where land management practices can contribute to climate change. The Finlands are an example of a landscape. They were drained in the 17th century, and less than 1% of the original wetlands remain in a very fragmented state. The peat that's there provides a very rich agricultural land, but is eroding rapidly and contributing significantly to greenhouse gas emissions. But at the same time, the region is very exposed to climate change. It's much of it's below sea level, and it's one of the driest parts of the country. And those risks are exacerbated by the impacts of climate change. So the challenge is, can we look to be managing the land differently in a way that benefits people and nature and climate? Any new approach needs to be designed holistically in collaboration with those people who live and work in the region. And that's where this whole systems approach is absolutely central. We need to understand how to transition the landscape, but at the same time help support the local economy and address the very severe social challenges that exist in the region as well. Well, some citizens' jury helped coordinate a citizens' jury. That was an emphasis on the importance of listening and of ensuring all solutions are fair to all those stakeholders who are involved in that landscape. So where does that leave us? In the context of a global pandemic and globally reverberating implications of the Russian invasion of Ukraine for cost of living, climate change is the most predictable and the most preventable global crisis. In the UK, we're already experiencing the economic and human costs of extreme heat and flooding, with climate-related risks, for example, in terms of failures to critical infrastructure and the way in which they can cascade, only just starting to be understood. Our natural world is already under pressure, and that's exacerbated by climate change. And in a globally interconnected world, the risks posed by climate change fueling the underlying causes of migration and of violent conflict are clear. There are risks too from climate change or ill-conceived responses to it exacerbating social inequality, or from climate-induced redrawing of geopolitical maps. But where there are risks, there are also opportunities, and climate change can equally be seen as the most predictable and exploitable innovation opportunity. Capitalizing on a long tradition of creativity and ingenuity and a strong knowledge economy, the UK is in a powerful position to lead and gain competitive advantage from the transition. And coming from the University of Cambridge, where we're undertaking significant amounts of research across each of the dimensions of the innovations that are required to deliver a net zero economy across every sector, I can see the huge opportunities, whether it's in terms of new battery technologies, net zero aviation, the application of AI and digital technologies, sustainable agriculture, supporting a circular economy, greener materials in our buildings or in our industrial processes, or natural or engineering approaches to greenhouse gas removal. Opportunities really do abound. As Patrick emphasised at the start, we need these opportunities that are already in development to be scaled up, and a pipeline of innovations to take us through the coming decades. An exciting, greener, cleaner, healthier and more prosperous future could await us if we chose to embrace it. And I'll leave that and hand over to Gideon.
Thank you, Gideon. If you can just round this off on adaptation, that'd be great, and then we'll stop and hand over to questions.
Oh, thank you. Someone has shared for me as I was about to try sharing, so thanks very much, presumably Go Science, for doing that. So as the CSA at DEFRA, we do have responsibility for some of the sectors that Emily has mentioned in her talk: agriculture, land use, waste and F-gases. But I'm not going to focus in on those sectors here and on the challenge of reducing emissions, but instead focus on the other aspect of climate change, adaptation, which is an area that DEFRA hold in particular for government, although the risks really do span multiple government departments. And before I dive into the slides, let me just make it clear that we know, as others have said, that climate is already changing, has already changed, and it will continue to change in the future. And although it's an urgent need to limit that change and limit the damage of climate change, regardless of our success to adapt to the coming climate change, and costly as our efforts to reduce emissions are less successful. So there's a very strong playoff between the need to mitigate and our need to adapt to the coming climate change. Now, I thought I'd start my presentation with a slide which builds on the comments that Stephen made at the beginning, as we're about to enter one of the heat waves of this year, a big heat wave coming this year. But this is a slide from the Met Office which shows what a heat wave might look like, or a typical summer day even might look like by 2050, at the point at which we hope to have reached net zero, with significantly higher temperatures than we experience today. Temperatures that we need to see coming and we need to be ready to adapt to. And this slide also reminds me to say that I'm going to take a UK focus in this talk, but that doesn't suggest that the challenge of climate adaptation is only for the UK, only that I'm dealing with this in the UK government aspect. So next slide, please. Now, others have shown pictures of global temperature rise that we've already observed. I thought I'd show this in a different form, in this by now hopefully familiar climate stripe figure that really shows visually and in a publicly accessible way the impact of climate change. And here's showing the climate stripes specifically for the UK, demonstrating that in the UK as globally, temperature has increased significantly recently, with the 5 warmest years since 2006 and the 5 coolest years some time ago in the past. Clear visual demonstration that warming is something we need to get used to in the UK. Next slide, please. That is regardless of where you live. And here are just 5 different cities around the UK which demonstrate very much the same trend, subtle regional differences, but in all of these we see the strong impact of warming as you go through observational record of the last 100 years. And this is what we need to be ready to adapt to. Next slide, please. And if we put this rather than in those visual approaches into a form more familiar and comfortable with our scientists, and put it in graphical form, here you see the impact of climate that we've already observed for the UK, with temperature rising more than a degree shown in the upper panel here. And you can see this is a UK only graph now rather than global. Clear evidence for the UK's temperature increasing in the observational record as well as globally. In the middle figure here, you see rainfall with a very slight increase annually, and I'll come back to that later. And in the lower panel, you see sea level rise of the observed record, with something like 16 centimetres of rise on average for the UK during the last 100 years of observations. So this is the change that we've already observed. Next slide, please. We can also look at what is coming in the future. And I think it's worth just pausing here for a minute and recognizing the tremendous success of science in being able to do this. What I've shown so far is the observations we've made, but the science of climate change is now very mature, and we're able to predict what will happen to climate for particular actions of humans. So we know if we follow a particular emission scenario, we can predict what the outcome of that will be. There are multiple mechanisms and processes that have gone into those sorts of predictions, but I thought I'd mention one in particular, the UK climate projections, which are a formal process that government goes through to set out what we expect will happen to climate in the future based on different emission scenarios, with the last one of these UKCP products being produced in 2018. And I'll show you a couple of these slides to show you the coming temperature and rainfall for the UK that we have to be ready to adapt to. So the first one of those shows expected temperature. This is for a scenario which isn't quite reaching net zero. It's for an innovative future scenario, but one which doesn't get to our net zero targets by 2050. And it shows that summer temperatures might increase by 4 degrees in the south of the country, a significant change of temperature and very difficult to adapt to. And there'd be uniform increases of something like 2 to 3 degrees, even in the winter, with significant changes, for instance, in frost days and with implications for pests and such like in the future from those frost day changes. Next slide, please. As per the last slide, this is now showing rainfall again for 2080 from that UKCP prediction, so the predictions that we run on behalf of government here, showing that in general, in the summer, what we anticipate as climate changes is a decrease of rainfall, and in the winter, we anticipate an increase of rainfall. So this exacerbates the problems that we already have with greater propensity towards drought in summer and greater propensity to flooding in the winter. And unfortunately, climate has a nasty trick of doing this around the world, that in general, rainfall increases in the wet areas and decreases in the dry areas as we go into the future, making adaptation more challenging. So these images have shown you the challenge that we face with a changing climate, which others have spoken about, but which I've now introduced with a specific UK focus. Can we go to the next slide, please? We know that, as others have said already, that extreme events are already occurring in the UK, and our climate predictions enable us to look into the future and say that these will become more severe and will need careful planning. If I run through these quickly, you'll see heat waves that, like the 2020 one, where 2020 heat wave caused more than 2,000 excess deaths in the UK. And we expect to see those heat waves increasing, as on my opening slide, so that by 2050, hot summers such as 2020 could occur every other year. We must see those coming and be ready for those extreme summers to become commonplace. If we look at heavy rainfall, again, 2020 was the wettest February in the UK on record, with substantial flooding as a consequence, particularly during some of the major storms. And by 2070, we can expect winter rainfall events similar to those storms to be commonplace or more commonplace, with an increase of about 25%. Again, a challenge that we need to be ready to adapt to. And on wildfires, as in many other areas, there are also extreme events that are increasing now and will continue to increase into the future. Next slide, please. And the assessment of these climate risks and our need to adapt to them is part of the formal process laid out in the 2008 Climate Change Act and formalised in the Committee for Climate Change activities. One of those is the requirement for Committee for Climate Change to help government to lay out a periodic climate change risk assessment, with a third one of those having just occurred, the CCC advice in 2021 and the government response largely following that advice happening shortly afterwards. And this risk assessment lays out for us the challenges that we know are coming to all sectors of the UK society and industry. And those are summarised on the next slide, please. You won't be able to read this, but I'll blow up a portion of it in a minute. The critical thing to identify here is that the CCC report and the government climate change risk assessment identifies 61 discrete risks and opportunities. They're titled risks and opportunities, but in nearly all cases, these are actually risks with significant possible negative consequences, which we must see coming and be ready to adapt to. If we go to the next slide, you'll see that there's a blow up here that shows you just some of those risks. If you haven't looked at the CCRA report, I encourage you to look at it and look at the sectors that you're most interested in. And here you see just some of them. If I point to the ones in the top left and then at the bottom middle, you'll see that one of the aspects of heating is to see significant increases in negative health outcomes to our agricultural system, to our forestry, and indeed to humans, through a temperature rise leading to pests and diseases being able to spread to higher latitudes where we live here in the UK. And I won't, in the interest of time, won't go through other risks here, But there are, as I said, 61 of these specific risks identified that we need to be ready to adapt to in the future. I'm just going to focus in on a couple of these in particular now, as Emily did, following on two of these, and you were right. Next slide, please. And I'll first of all talk about one of the risks to agriculture. We know that climate change is going to increase in the summer months thermal heat stress on livestock. And that temperature change and the change in rainfall is also going to lead to an increase in the likelihood of pests, as I've already mentioned, including potato blight. And we can model and understand what the implications might be of those changes in the future. And that's summarized on this map that you see on the left here. And on this map, you can see in red the regions where most of our cattle come from and where we have actually some very significant change in heat stress as a consequence of climate change going into the future by 2060, with a 10 to 20-fold increase of days at which cattle will be under heat stress because of climate change. In the brown areas, you see that we also see increases in the propensity towards potato blight, and the brown areas here are those where we grow most of our potatoes. So you can see both in crops and in livestock the challenge of future climate change on our agricultural system, which we need to be ready for by thinking about livestock nutrition, management, genetic selection, and for potatoes, thinking about growing blight-resistant varieties in the future. Next slide, please. The other example that I'll mention here of the many risks is that risk associated with sea level rise. As in many of my slides, I'm again using one here from the Met Office, which is adapted from the UK climate projections that I mentioned. Here you see expected sea level rises by the end of this century in the 4 capital cities of the United Kingdom. And you see in blue bars here the expected sea level rise for a low emission scenario that we obviously hope to follow, and in red the sea level rise which goes beyond a metre in the south for a high emission scenario. Sea level rise is clearly going to become increasingly problematic. As I think Emily has said already, this is a major challenge that we need to see coming in terms of our coastal defences, including of most of our major cities, which are generally coastal and hard to defend. And as you'll see on this figure, it's across the whole of the UK, but particularly acute in the south because of the gradual tilting of the UK. So we can expect particularly areas like London to be negatively impacted by sea level rise, with the Thames barrier, for instance, needing replacement as the century goes on, and London possibly becoming undefendable as we go, if we were to pursue a high emission scenario. Next slide, please. The CCRA process that I've already mentioned also points to the individual risks that come from that sea level rise, with issues like coastal squeeze, a term you may not have heard of here, but this refers to the fact that because of the amount of growth of infrastructure on our coasts, it makes the coastal evolution, the natural evolution of coastlines, more challenging if you have concrete and other infrastructure on your coastal areas. And these are challenges that we need to be ready for as we go into the future. These are challenges like this in all different government departments and across all sectors. Next slide, please. Now, I said I'd focus on the UK, and I indeed have done that. I just wanted to throw in one slide before I close to remind people that these adaptation challenges are across the planet, not just in the UK. And as Caroline and others have pointed out, we started the Industrial Revolution. We will suffer because of the CO2 emissions, because of our climate change, but other parts of the world will suffer even more so, particularly in tropical regions, where multiple severe impacts of climate change will cause significant perturbations with potential geopolitical and international consequences, which might also impinge on the UK. And for my final slide, if you could move on, thank you, a summary here of what I think others have talked about as well as me in this rather nice image from the Met Office, showing in concentric circles in the middle the cause of the change are greenhouse gas emissions, which we know is what drives climate. In the middle ring here, the impacts in our climate system of things like sea level rise, increasing temperature, more extreme events. and then around the edge, the challenges that we will need to adapt to, and the way that these climate changes will cause perturbations to the systems in nature that we rely on for our society and human health, as well as for planetary health. So I'll leave it there, and like others, I'm sure I'm very happy to take questions.
Thank you very much, Gideon. Thanks, Emily. Thanks, Stephen. I think let's go straight into questions, Caroline. I'll leave that to you to take the questions and direct them as you wish to us.
Lovely. Thank you so much, everyone. Incredibly so.